Okay, let me just erase this part. All right, so we have a question here. It's dealing with linear regression. As I said, linear regression, this shows how certain variables relate to each other with an equation, okay, with a linear equation. So in this case here, we're trying to see the relationship between GDP, capital investment, external debt, trade openness, and the labor force. All right, we're trying to see the relationship with GDP and these factors here. We're evaluating this relationship through this equation. Okay, colleagues? Multiple linear regression, you're just showing the relationship of certain variables using a linear equation. And in this case, the relationship we're trying to investigate is the relationship of GDP with capital investment, external debt, trade, and the labor growth. So part one of the question asks us, what does the term ln and E1 represent? This ln here represents the natural log. The reasons why we use natural logs in linear regression is because some relationships may not, they can, like for example, this same equation here, if we removed the natural logs and try to plot it, you might get a graph like this black line which you can see here. All right, a non-linear line. Non-linear lines are hard to evaluate and interpret. Okay, so what the natural log would do is it will convert a non-linear line like this black one here into a straight line here. A straight line is easy to evaluate. Okay, so that's why we're using the natural logs, okay, to help us investigate non-linear relationships that can exist. Then E1, the error term, represents everything else that affects GDP that isn't included in the equation. That is part A. Any questions on that, colleagues? Before we move to part B, natural logs, ln natural log, E1 error term. Error term accounts for things that haven't been included in our equation. And the natural log is used to convert a non-linear line into a linear line so that we can easily investigate how the variables interact with each other. So this is a very important topic because when you'll be doing your fourth year researches, you might have to, some of you might have to form a linear relationship and see how the relationship is. Okay. Madam, could you mute your mic? Could you mute your mic? Okay, part B, it says identify the dependent and the independent variables used in the, regression analysis. So as I said, here the dependent variable is GDP, which is the gross domestic product. This is the dependent one. And then the independent variables, capital investment, external debt, trade openness, and the labor force. These are the independent variables. These are the variables that influence GDP or affect GDP. Okay. GDP is dependent on these variables there. Part C. Comment on the direction and the significance of the relationship between the dependent variable and each of the independent variables. Okay, so here we're going to be analyzing the relationship of GDP with first capital investment. We're going to see those two, the relationship. Then we evaluate the relationship between GDP and external debt. Then again, we evaluate the relationship between GDP and trade openness, and then GDP and the labor force. So where we are going to see that is under this section of the table here, the coefficient section here. Okay. Now, they've asked us first to comment on the direction. All right. So first, let's evaluate the relationship between GDP and capital investment. All right. The coefficient for capital investment here is this one here, 0.094. Okay. Now, since this coefficient is positive, okay, because the direction here, where that's commit to the direction, we're looking at the signs of the coefficient. Okay. If the coefficient has a positive sign, it means if you put GDP here and capital investment here, if capital investment increases, GDP is also going to increase. Okay. So it's like they're moving in the same direction. Okay. If your coefficient has a positive sign, okay, if the coefficient has a positive sign, then it means if the independent variable increases, in this case, if capital investment increases, then GDP is going to increase. Okay. So they are moving in the same direction. If capital investment decreases, then it also means GDP is going to decrease. Colleagues, are we okay with that? Any questions? Okay, so here we're just looking at the signs of these coefficients, all right, to see the direction. Okay, yes, positive, it means yes, yes, uh-huh, yes. Oh, this graph I was showing, it shows what's this, where two variables are moving in the same direction. Okay. Yes, you have a line like this. Okay. Yes. Then, if they're not moving in the same direction with a negative coefficient, then your line is going to move like this. Yes, meaning when the independent variable increases, the dependent variable will decrease. And yes, 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 yes. And doesn't this remind us of the law of supply and demand? Have you seen law of demand, downward sloping inverse relationship? Uh-huh. Yes, so that's what's happening here. Okay, then this number here, this 0.094, okay, if capital investment increases by 1 unit or 1%, okay, GDP is going to increase by, we convert this into a percentage, it's going to increase by 9.4%. Okay, this 0.094, if you convert it into a percentage, it's 9.4%. So if capital increases by 1 unit, or it increases by 1%, then GDP is going to increase by 9.4%. So in terms of the direction, capital investment and GDP are moving in the same direction, okay? Because this is a positive coefficient here. Then the second thing we have to comment on is the significance of the relationship. This is where we come to focus here on our p value, our probability value. Okay. The rule of thumb, if this value is less than 0.05, if any of the values are less than 0.05, basically what it's saying is this relationship is not by chance and the relationship is significant. Okay. So as we can see for capital investment, our p value is 0.0026. 0.0026 is less than 0.05. So what this is telling us is the relationship between GDP and capital investment is a significant relationship. It cannot be ignored. It's a significant relationship. If your probability value is less than 0.05, then the relationship is significant. Okay. If your probability value, okay, the p-value rule, this is called the p-value rule. If your probability value is less than 0.05, it means the relationship between the variables is significant. There is a true relationship that it means that capital investment actually does affect GDP. If it's not significant, then it means capital investment doesn't affect GDP. Yes. No, 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 it's okay, sir. Please remember, ask as many questions as you want, okay? Questions are welcome. eh? Then there the relationship is not significant. There's a high chance that if there's any effect, it's by chance. Okay. So what it's just telling us is there's no relationship between the variables. And it's what you as a statistician should know is you should even remove that variable from the equation. Okay. Okay. Remember, colleagues, questions are welcome. That's how we learn. Okay. Yes. All right, sir. Have I answered your question? Okay. You're welcome. Welcome. Feel free to ask any others. So next, so we've evaluated the relationship between GDP and capital investment. From the coefficient, since it's positive, it means they're moving in the same direction. If capital investment increases by 1 unit or 1%, GDP is going to increase by 9.4%. Then when you come to see the significance of the relationship, our p-value is less than 0.05. So this relationship is significant, meaning in actuality, capital investment does affect GDP. So I'll send you the notes. I'll send this document again it's got all the notes you can read on. Okay. Yes, yes, yes. I put notes which you can go through. Okay. Next, we're now going to see the relationship between GDP and external debt. Okay. So we come here. excuse me, we see the coefficient. Now here we can see a negative coefficient. Okay, so it means external debt and the GDP are moving in opposite directions. So if external debt increases, GDP is going to reduce. Okay, so if external debt increases by 1 unit or by 1%, GDP is going to reduce by 0.525, that's 52.5%. So it seems external debt has a big influence here because, colleagues, if you check on also the p value of external debt, it is 0.000000, way less than 0.05. Okay, so this is what it's telling us, that there is a strong relationship here between external debt and GDP. And amongst all these variables, I would say the strongest is with external debt because its p value is the lowest. Okay. So the relationship between external debt and GDP is very significant, and they are moving in opposite directions. If external debt increases by 1 unit or 1%, GDP will reduce by 52.5%. So this nation should not get more debt, because if they get debt, they have to pay back that debt. So that money they're using to pay back the debt is not being used to be more productive. But remember, GDP is the total market value of the goods and services produced within a nation. So it's more about productivity. So now, if Zambia is channeling the money to pay that external debt, it means less money is being pumped into productivity within the nation. Trade openness, TR here. Now, oh yeah, so now we're evaluating the relationship between GDP and trade openness. Right, so we can see again there's a negative coefficient here. So it means they're moving in opposite directions. So if trade openness increases by 1 unit or 1%, GDP will reduce by 31.9%. We evaluate the how significant the relationship. Here we have 0.0257. 0.0257 is less than 0.05. So this is a significant relationship, meaning trade openness does affect GDP. Okay, here once if you say the relationship is significant, it means that variable does affect GDP. And then finally, we oh, someone wants to join. Okay, now we see the relationship between GDP and the labor force, POP. So we have a positive coefficient, meaning if the labor force increases, GDP is also going to increase. So if labor force increases by 1 unit, right, GDP, so this, if converted into percentage, is going to increase by 11.89%. So here, when I said 52.5, I mean these will be percentages. So here for external debt, it was if external debt increases by 1 unit, GDP reduces by 0.525%. Here it's by 0.319%. Then here 11.89%. Don't multiply them by hundreds. So if the labor force increases by 1 unit, GDP is going to increase by 11.89%. Yes. And the significance, since it's less than 0.05, it means the labor force does affect the GDP. Questions? Okay, part D, it says state and interpret R squared adjusted value obtained. Okay, this R squared here, right? So what this adjusted R squared tells us, it tells us how good the factors we've chosen in the model, how good they are in explaining changes in GDP. Okay. Basically, you want to see if your model is good with the factors chosen. All right. Adjusted R. You want to see if your model is good, if your model is good with the variables you have chosen. That's what the adjusted R is telling us. Okay. So R is between 0 to 1. Okay. The closer it is to 1, the better your model. Okay. It means you have picked the correct variables in your equation because they're explaining any changes that happen in GDP. Okay. So as we can see with our R here, it's 0.759. Okay. Which is almost close to 1. So it means these variables we've chosen here, okay, they truly affect GDP. If your adjusted R was, let's say, 0.1, then it would tell you that these factors that you've put in your equation, they are not good because they're not truly explaining any changes in GDP. Okay, so that's what adjusted R is telling us. Want to see the factors chosen in our model, how good they are. And the closer it is to 1, it shows that the variables you've put in your equation, they fit the model well. And if it's close to 0, it means you have to change those variables in your equation. You need to find new ones because they don't truly affect the dependent variable. The variables you have chosen. So that's what adjusted R squared is. You just want to see if your model or your equation is good with the variables that you've put into the equation. Part E, interpret the coefficients on external debt and labor force. Okay, so that was what I was saying earlier on here. Okay, if we look at the coefficient over labor, external debt first. Okay, external debt 0.525, meaning if external debt increases by 1 unit, 1%, GDP reduces by 0.525%. That's the interpretation of the coefficient. If external debt increases by 1 unit, 1%, GDP will reduce by 0.525%. And there's another additional column that helps us to see the preciseness of our coefficients, which is the standard error. The smaller the standard error, the more precise your coefficient is. Meaning, if you run this test again, all right, you might get a value close to 0.525, okay, because we've got a small standard error here. So if you run the test again and again, your values for your coefficients for external debt are not going to deviate far from 0.525, okay, because it's got a small standard error here. So the interpretation of the coefficient of external debt increases by 1 unit, GDP reduces by 0.525%. And this is a precise value because of what our standard error is small. With our labor force, if labor force increases by 1 unit or 1%, then GDP will increase by 11.89, excuse me, 11.89%. Now our standard error here is sizable 5.275. So it means if you run this test again, you might get a 16.89. You might get it's 11 minus 5, that is 7. You might get it somewhere 7 something. Your values might vary, okay? Because our standard error is kind of big. So if you run this test again, you might get different values of the coefficient for the labor growth. Yes, that is part one of the question. Any questions, colleagues, before we move to question two? Okay, okay, move to question two. Now, this is where real mathematics is going to happen here. I would advise you get your papers and pens, colleagues, because we're starting with integration. One practical use for integration is it determines areas under graphs. Okay, if you draw a graph and you want to determine the area in that graph, you can use integration. Okay, just wait for the board to load, then we'll start solving. Where was I kicked out, colleagues? Hey, that far. Okay. R squared, as I said, it helps you to see if your equation is good enough with the variables you have chosen. Okay. Is your equation good enough? Does your equation truly explain any changes in GDP? So the R squared use a scale from 0 to 1. The closer it is to 1, the better your equation is. It's telling you that the variables you've put in your equation are good enough. They truly explain the changes in the dependent variable. Have you got that explanation, sir? You just want to see how good your equation is with the variables that you have chosen, that you have put in there. Okay? That's what I just, yes, yes. If you adjusted R is close to 0, it means the variables in your equation are not that good enough. They need to be changed. Okay? Because they're not truly explaining any changes in the dependent variable, in this case in GDP. Mhm. Yes, where it says interpret the coefficients over external debt and labor force. So as yes, so as I said, if we go to external debt, this is our coefficient. So what this is telling us is that if external debt increases by 1 unit or 1%, GDP is going to reduce by 0.525%. If external debt increases by 1% or by 1 unit, GDP will reduce by 0.525%. Yes, that's why it's reduced. Yes, why that's the reason for the reduction. Yes, yes. Then the standard error, it's showing you how precise your coefficient is. Okay, the smaller the standard error, the more precise your coefficient is. Meaning, if you run this test again, your values will be close to this 0.525. Okay, they won't be far from it. Okay, yes, the more precise your coefficient is. Meaning, if you do the test again, you won't get a value that's far from 0.525. Yes. Then for labor force, okay, if the labor force increases by 1%, GDP is going to increase by 11.89%. Because it's positive, so they're moving in the same direction. So if labor force increases by 1 unit or 1%, GDP will increase by 11.89%. Now, if we look at the standard error, it's not really that big, but it's kind of compared to the other ones. So it means if you run this test again, you might get some values that may not be 11. You might get a 12, you might get a 13, a 14, you might get a 10, a 9. All right. The bigger the standard error, the bigger the variability in your coefficient. Meaning, if you run the test again, you won't get values that are close to 11.89. So it's not, this coefficient is not very precise in simple terms. Yes. Any questions before we move to question two? So when we have free time, I'll show you how to do this type of regression on Excel. Okay, these things you can do them on Excel. Yes, you can do them on Excel. And those who are doing BBA, third year in managerial economics, even I think in management accounting, you'll see the same topic, multiple linear regression. So, yeah, when I have time, I'll show you how to do this on Excel. Okay, we can go to question two. Before we go to question two, these are the laws of logarithms you need to remember. Please write them down. Because these, especially these three, they are going to apply throughout this whole. You're going to see these laws being applied in. Excuse me. Sorry, I was drinking Coca-Cola. Yeah, you're going to see these laws get applied in a lot of questions. So kindly write them down so that as I'm solving, you're not thinking I'm doing witchcraft. Okay. Eh, Yes, basically, throughout mathematics. Okay. Yes. So this is the basic rule of integration. Okay. Also write this down. Yes. The root of n. Mhm. This is the basic rule of integration. And each time you see that integral sign there, this is what's going to be happening. So let me just give a small demonstration of this same rule. All right. So for example, if you have x to the power 4, what this entails is you say x to the power 4 plus 1 divided by 4 plus 1 plus c. Now, the reason why this plus c is coming is because integration is the reverse of differentiation. Okay, so this c just represents the constant term. When you hear the word constant term, it's just a number without a letter. Okay, colleagues? Constant term, number without a letter. So for now, please don't get confused by that C, okay? Just focus on what I'm doing. 4 plus 1, that is 5. Yes. So this is an illustration. X to the power 4. So here the secret is, colleagues, is remember the exponent, this power, always add a 1. Then the operation you're doing with the exponent, put it in the denominator. Okay. The exponent always add a 1 to it. Then the denominator. What you've done with the exponent, do it in the denominator. Have you seen this 4 plus 1, which you did with the exponent? It's come down here in the denominator, 4 plus 1. How many people used to dodge mathematics in high school? Your nightmares have come. Here, you will remember those days. Yes, there was a question. Is it Mr. Christian? Okay, okay, okay. All right, colleagues. So please just the way I've done this here on top is what's going to be done in this question. Okay. Then these laws, you're going to see where I'll apply them. So let me bring the question now here. Oh, and one more thing I need to mention. If the integral has got limits, like in our question, then this C won't be applicable. Okay. If the integral has got limits, meaning it's got a number here on top and a number down, this C won't apply. Okay. So here, let me write it. Integral of 4, 1. Please let's get our papers and pens so that at least we even try to see if we'll get anything. Okay. So with this question here, colleagues, first thing first, we need to integrate x squared. We integrate 4 and we integrate 4x to the power negative 2. Okay. So we're going to be integrating with that with the way we did it here. So on your papers, try to integrate x squared. Let's see, let me hear the answers when we integrate x squared. Wonderful, sir. Wonderful. Yes, yes, yes. Mhm. Yes, negative 4x. Colleagues, magic happens in mathematics. There is magic, okay? 4x is the same as 4x to the power 0, okay? So this 0, we add a 1 over 0 plus 1. So that's how we got 4x. 0 plus 1, 4x to the power 1 over 1. Are we okay with that? Any questions? Okay, the next one. Yes. Wonderful. Yes, yes. And remember, with mathematics, the secret is in the exam, show all the steps, colleagues, all right? Please show the steps so that you can maximize on your marks. Because if you skip a step, some questions you lose. By skipping a step, you lose zero point 0.5 marks, depending on who is marking your paper. Yes. Any questions before we move further? Okay. So now, this x to the power negative 1, excuse me, we're going to apply this law here, all right? So that we can make this negative exponent positive, all right? So what we're doing basically is this 4 over 1 times, so x to the power negative 1 is the same as 1 over x to the power 1. Okay, so when we do that, plus, so we have 4 over negative 1x. Then since we've got this negative sign here, this negative and positive, they make a negative. So this, yeah, so this becomes minus. Okay. Because of this negative 1 here at the bottom, okay. So when these two interact, it becomes negative. Yes. Any questions before we go to the next part? Okay. So now what happens is these limits, these 4, we're going to substitute it. Where there's x, we're going to substitute it with 4. Okay, throughout the equation. Then we subtract it by this same function. But now, where there is this 1, we'll substitute it with x. So let me show you what I mean basically. So first we start with substituting 4. So this x to the power 3, it becomes 4 to the power 3 over 3 minus 4. This x will substitute to another 4 minus 4 over 1 times 4. Let me just admit, I think someone was trying to join in. Okay. Yes, so then minus. Now this same function. Now, where there's x, we're going to substitute 1. So this x to the power 3 becomes 1 to the power 3 over 3 minus 4 times 1 minus 4, yeah, 4 over 1 base, because 1 times 1 basically is 1, so 4 over 1. All right, colleagues, now here we're back to grade 3 mathematics here, because this is not difficult to solve. Um, yes. Mm-hmm. Yes. 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 Okay. Any other queries? Okay. Yes. Yes. You have seen how simple it is? Uh-huh. Yes. Okay. Are we all okay with that, colleagues? Remember, no one should be left behind. We are together until fourth year. Okay. When you're graduating, I'll be part of the people clapping for you. Okay. So no one should be left behind. Okay. I know mathematics and women, they do not get along, but colleagues, this year just try to love mathematics. Okay. Do not hate it, just try to love it and understand it. Okay. If you're doing HRM, those who are doing human resource management, at this third year, you can say bye to any kind of mathematics. Maybe you might see a bit, but yeah. But those doing accounting and finance, BBA, you're going to find more of this. I don't know about project management, and is it marketing? I do not know. So, love this subject. Okay, colleagues, 4 to the power 3. All right, so 64 divided by 3. Is it divisible by 3 so we make it a whole number? Okay. So those who don't like fractions, you can convert into decimals, okay? If you do not like fractions, just get decimals and you make your life easy. Okay. So I'm just doing it step by step so that everyone is. So 4 divided by 1, it becomes 4 here. 4 divided by 4, it becomes 1 here. I hope we're all okay with that. Okay, so let's solve here now. Let's see what answers we get. So to make life easy, you can start -1, -16 minus -1, that is -17. So you can do 64 over 3 minus 17. As I said, if you want decimals, just do 64 divided by 3, whatever decimal you get. Those other fractions. Then here you can say negative 4 minus negative 4, that is negative 8. Now I believe this part, okay, even a grade 2 can solve it. Network. Oh, ha! Thought network kicked me out. Last time when we were doing a class like this, I was kicked out at the same point here once we reached this part. So, okay. Are we able to see my board? We've reached the part 64 over 3 minus 17 minus open brackets 1 over 3 minus 8. So maybe let's solve that as I'm trying to refresh the board. Why isn't it refreshing? Refresh. Yes, we're doing 64 over 3 minus 17, close brackets, open brackets again, 1 over 3 minus 8. So you can let me know what values you've got as I'm trying to do this here. Am I still audible?